Well, hey, good morning, class. Happy whatever day it is while you're watching this video. So today's lesson, we're starting up chapter 6, which is all going to be about how we go about solving systems of equations. So we're going to show you various methods of solving them, and hopefully you'll get a good understanding of this as we go through. So our first lesson here, 6-1, graphing systems of equations. So one of the ways that we can solve a system of equations is by graphing. But first of all, what is a system of equations? So in your notes here it says a system of equations is blank. So it's sorry about that. Forgot to be on pen mode. It is two or more equations with the same variables. So you have two or more equations. So in the examples down here below, notice how I have two equations, and I have two unknowns, x, y, x, y. Here I have three equations, and I have three unknowns, x, y, z, x, y, z, x, y, z. So ideally when solving systems of equations, you want to have the same number of variables as equations. That's ideal. Now, each equation doesn't have to have all the variables in it, but there's got to be that many. So again, here, notice two variables, x, y, two equations. Three variables, x, y, z, three equations. So one of the ways that we can solve them, especially when we only have two equations, you can do three, but it's really difficult to graph three. We won't graph three, but it's only when you have two equations is by graphing. So this is somewhat of a nice review, a little bit of chapter 3, because we're graphing equations of lines, and it's going to be a nice review of slope, y-intercept, and all that fun stuff. So now when you actually solve by graphing, you can actually have three different things happen when solving systems of equations. The most likely option or the most likely solution that we'll get is we're going to have simply one solution, and that's where the lines intersect. So we have intersecting lines. So you might have one line here. So this might be equation 1, and you might have another line right here. This might be equation 2. The point in which they intersect here, this coordinate x, y, is our solution. So x will equal the x coordinate, and y will simply equal the y coordinate. So we just got to find where they actually intersect. Now, the second type of solution we could have is actually what we call no solution. That occurs when we have parallel lines. So what happens here is if we have two lines and they end up being parallel, meaning basically they have the same slope, they will never intersect. Never intersect. So since they never intersect, okay, we have no solution. There is no point. Okay? Now, the last one, same line. What happens is the two equations can totally look different, but when you end up graphing them, here's the first line right here, okay? And then when you go to graph that second line, it happens to be the exact same line. So they end up right on top of each other. So what that means is every single point on this line is a solution. And since a line keeps on going positive and keeps on going negative, you actually have an infinite amount of solutions. So what we say is infinitely many solutions. Now, you'll see me later on abbreviate, and you can do the same. IMS, infinitely many solutions. So we're going to go through an example of each of these on how these actually happen. So how do we go about graphing it? Okay? So what's nice is I give you a nice step-by-step, basically step-by-step directions that you need to do in order to graph these. So when you are working on these, go back to this and follow these steps. It'll help you a ton. So on the first one, it says step 1, write each equation in slope-intercept form. Remember, slope-intercept form is y equals a plus bx. Now, a is the y-intercept, and b is your slope. Okay? Remember that slope is equal to rise over run. That will help us graph it. So then, 2, graph each line. So we'll graph each of them separately. Step 3, find the point of intersection or state if it has no solution or infinitely many solutions. Finally, check your answer. So one of the things you can do is plug it back into the equations and check to make sure it actually makes true statements. All right, so let's look at this very first one right here. We'll move this up just because it's a little easier if it's a little bit higher for me. So this problem here says solve the system of equations by graphing. So again, step 1 actually says, so I'll lower it back down now here for a second so I can see the step. Write each equation in slope-intercept form. Oh, isn't this nice? Y is all by itself, y is all by itself. I actually don't even need to do anything, step 1. Now, step 2 is to graph each of them. So the first one, I'm going to graph here in blue. So to graph it, I need to identify my key pieces. Y-intercept. This is where I'm going to start on the y-axis. So I'm starting at a positive 2. So remember, here's the x-axis, here's the y-axis. So on the y-axis, I'm starting at the point 2. Then my slope is 3. Now, if you get a whole number, write it as a fraction, 3 over 1, so that I can identify the rise over the run. Remember, this is how much I go up if it's positive, down if it's negative, and how I run, I go to the right 1 unit. Or I shouldn't really say 1 unit, I apologize. I run, however many units it asks me to do. So in this case, it says I should rise 3 units while I run to the right 1 unit. So I rise 3, run 1, rise, 1, 2, 3, run 1, rise. I kind of go off the grid. I'll just graph it anyway. Now to see the rest of them, you can do the opposite. So you can go down 3 to the left 1, down 3 to the left 1, down 3 to the left 1, down 3 to the left 1. So what's nice is I have all of my points. I can connect them all, and I got my nice, beautiful line. I do the same thing for the second equation. So on this one, my y-intercept, if I look at this one, is -6. So that means on the y-intercept, I start at 1, 2, 3, 4, 5, 6, -6. Now my slope here says -x. So that's like saying -1. So I can always put a 1 in front. -1, I now can put it over 1. So this means I rise, meaning I'm going to go down 1 unit, okay, while I run 1 unit that direction. So I'm going to rise, meaning I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So if I continue this pattern, it'd be like going up 1, but backwards, back 1, up 1. Ooh, look at that. I found where they've intersected. So I can continue this process, and I get myself my second equation. So now, I just need to figure out where the coordinates of this point is located. So here again is my origin where x and y axis cross is the origin 0, 0. So I'm going back 1, 2. So the x value is -2. My y value is 1, 2, 3, 4, -4. So my solution is -2, -4. So now one of the last things I do, okay, is I like to check. So just to do a quick check, I'm going back to this equation and seeing if it works. So I'm going to kind of do this way over here since I got a little space over here. So the y value is -4. Does -4 equal 3 times, put in the x value, -2 plus 2? So does -4 equal, multiply -6 plus 2? -4 does equal -4. Check. Now I do the same thing for the second equation. I do need to check both because it can sometimes work for one but not the other. So just a quick check, does -4 equal, okay, plug in negative, a -2, okay, so I'm going to have a -2 minus 6. So I have -4. Negative really makes a +2 minus 6. And -2 minus 6 is also -4. Check. So everything works out beautifully. So just like that, we've taken care of the first example. All right, so let's take a look at example number 2. So it says solve this system of equations, okay, by graphing. All right, so if I look at the first equation, I'll try to be consistent here as best I can. So here's my x-axis again, here's my y-axis. So I'm going to graph the first one in blue. This one's nice because y is all by itself. So, all right, my y-intercept is -3. So I start on my y-axis at -3. My slope is 2. So 2 over 1. So that means I'm going to rise 2 while I run 1. So rise up 2, run 1. Rise up 2, run 1. Continue that process. Rise up 2, 1, up 2, 1, up 2, 1. I can go down, do the same thing, so I get a really good picture of my graph. All right, so now the second equation, y is not by itself. Whoops, sorry. I could have swore I clicked on red there. There is, so here I got to get y by itself. So to do the second equation, to get y by itself, the nice thing is I only have to do one step. Just add 2x. So I have y equals 4 plus 2x. So now my y-intercept, in this case, is 4. Okay. My slope is 2 over 1. So on this one, I start at 4. 1, 2, 3, 4. I go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. I can do the same thing going down. So now, connect all my points. Ooh, what do we notice about these two lines? Look at how they are actually parallel. Look at their slopes. Notice how their slopes were exactly the same slope. And since they had the same slope here, and they don't intersect at all, we have no solution. So this one, you don't have to put in any points to plug in, check to see if you got the right answer. You can see clearly parallel, and kind of how I check is see if they have the same slope. All right, one last example for our notes here today. Okay, oh, I apologize, we got 2 more examples here. So let's take a look at example number 3. Okay. So in example number 3, kind of stay consistent, I'm going to graph the first one in blue. So here I have y equals -4x plus 5. So my y-intercept is 5. So I'm going to start at 5. 1, 2, 3, 4, 5. My slope is -4, and I'm going to put it over 1. So that means I'm going to rise, meaning I'm actually going to go down 4 while I run 1. So I'm going to go down 4 to the right 1, down 4 to the right 1, down 4 to the right 1. Kind of ran out of space. I could go up 1 to the left 4. So I connect my points. Look at how beautiful that line is. All right, so now, in order to graph the second one, okay, I got to get y by itself. I got to first get the x's to the other side. So I need to subtract 8x. So I have 2y equals 10 minus 8x. Divide everything now by 2. So I have y equals 5 minus 4x. So here my, kind of got ahead of myself. My y-intercept is 5. My slope, -4 over 1. When I go to graph this, look at what happens. There it is at 5. Slope down 4 to the right 1. Down 4 to the right 1. Oh my goodness, I'm getting exactly the same equation. Even though it looks a little different, okay, these are exactly the same equation. It's just I've kind of wrote the 5 first, then the -4. Here the -4x was written first, then the 5. Okay? But it's the exact same equation. So when that happens, you get infinitely many solutions. And how I check that is my equation exactly the same? In this case it is. All right, one last example. Okay? These are the harder ones when you have to get both x and y all by itself. Okay? So the first thing, okay, that you'll need to do, okay, is to take the 2x and move it to the other side. So for this equation, I'm going to subtract 2x and subtract 2x. So I'm kind of doing it up here. So those are going to cross out. And all of a sudden now, see how y is all by itself? So I have y equals 7 minus 2x. So now my y-intercept is 7. My slope, okay, -2. So I go to graph. So when I look here, y-intercept, 1, 2, 3, 4, 5, 6, 7. Slope is 2, so -2 over 1. So I'm going to rise, meaning I'm going to go down 2 as I run to the right 1. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. So I can kind of continue that process. I'm going pretty far so that I get a good idea of what my line looks like. All right, so now I'm going to do the same thing for the second one. So I got a little more work to do on this one. So I got a -4x. So when I do, x's cross out. 3y equals 15 minus 4x. Okay. Then divide by 3. Divide everything by 3. So y equals 15 divided by 3 is 5. Minus 4/3 x. So now, and I leave that as a fraction because it's easier to graph the slope that way. So if I look here, my y-intercept is 5. My slope, and I always like to put the negative with the top number, -4/3. So what it means is the rise part is I'm actually going to go down 4, and then I'm going to run 3. So I start at 5. So 1, 2, 3, 4, 5. So this means I'm going to go down 4. 1, 2, 3, 4, run 3. Look at that. I get the intersection right away. Okay, down 4, run 3. So I'm just going to kind of connect those since I see where the point of intersection is right away. So now I want to find where this point is. So as I go to my graph, 1, 2, 3, up 1. So it looks like it's at x equals 3, y equals 1. So I state my solution, 3, 1. So then the last thing I need to do, step 4, is check. So I might just check it right down here. Okay, so I'm going to bring down this first equation. So I go 2, replace the x with 3, plus 1. Does that equal 7? Well, 2 times 3 is 6. 6 plus 1 does equal 7. Check. So that was plugged into the first equation. Now I'm going to plug it into the second equation and check. So 4 times 3 plus 3 times 1. Does that equal 15? 4 times 3 is 12. 12 plus 3 does equal 15. Check, check. My answer is right. I just rocked that problem. All right, so what I want you to do next is go over to your CFU worksheet right now, and I want you to first try these 3 problems, and then go to the CFU video and check out your results.